Good morning. Today we are going to see the ILD for reactions. ILD for reactions, and that is for compound beams. Compound beams. So now we are with a beam ABCD. So we have this is RA. Then we have this point B 3 meters. Then we have RC. And then we have this as RD. So this is 2 meters. This is 5 meters. Now we have to go for equations. So first we will consider unit load between A to B. So we have this as x distance. Unit load A to B, and in this we have equation moment about B equal to 0. We are going to consider the left part, and then we have moment about B0, so RA into 3 minus 1 into x, and that is equal to 0, and therefore we have RA equal to x by 3. Then we have another equation, moment about B0. Now we have right part, and then we will get it as RC into 2 plus 7RD, and that is equal to 0. Now we have summation Fy equal to 0, and we have RA plus RC plus RD, and that is equal to 1. And from this we will get RC plus RD, and that is equal to 1 minus x by 3, because we have value of RA x by 3 goes on right, becomes 1 minus x by 3, and that is equal to 3 minus x by 3. Now we have 2RC plus 7RD, and that is equal to 0. We will multiply this equation by 2, and then we will have 2RC plus 2RD, and that is equal to 3 minus x by 3. And then if we will solve this, we have this as minus, and then we have this as minus. Sorry, we have to multiply it also by 2. So into 2. And then we will get this as, so this will, if we will solve this RC gets cancelled, and we have this as 5RD, and that is equal to, so we can have 6, or 2 by 3 we will take outside, and then we have x minus 3. And then if we will put RD over here, then we will have this 2 by 15 in bracket x minus 3. Then we need not require to find value of RC, or you can find from this also, but once we know RA, RC, then RD, RA, RD, then RC we can find. So if you want, you can write equation and you can find it also. So now we will go with table. And then we can have this as first serial number. Then we have joint. Then we have value of x. Then we will calculate value of RA. Then we will calculate value of RC. And then we have calculate value of RD. We should be very careful. We have total value that is equal to 1. So now we have first, that is serial number 1, joint we have A, X we have 3, and then RA we will get it as RA, that is equal to 1, because we have RA X by 3 here, and therefore we will get 3 by 3 1. RD, if we will put X equal to 3, then 3 minus 3 we will get it as 0. So RD we will get it as 0. Then in RC plus RD, now here RD 0, and if we will put X equal to 3 in this equation, then we will get RD already 0, then 3 minus 3 upon 3 again 0. So RC also we have 0. Now we will go to the next part. We will be with second. We have at B. Then at B we have X equal to 0. So if we will put X equal to 0 in equation of RA, this equation, then we will get value of RA, that is equal to 0. Now we will put it RD. So we have RD, that is equal to 0 minus 3, and then we will get minus 3. So minus 3, if we will solve this at B, we have x0, and then we will have RD, that is equal to 2 by 15 in bracket minus 3. So 3 5s are, and then we have this value, that is minus 2 by 5. So minus 0.4. So we will substitute RD minus 0.4. And we can have this RA plus RC plus RD1. RA we have 0. RD we have minus 0.4. So RC automatically we will get it as 1.4. So we will have this. Now in this case, we have unit load between A to D. Now we will go to the next, where we have unit load is between B to D. What will be our equation when we have unit load between B to D? So I will write over here unit load B to D. And what we will get in this one? So now we have another diagram. So if we will plot it, so we have RD, then here we have RC, here we have RA, and this we have, that is B. This is 3 meters, 2 meters, 5 meters. And now we have unit load over here. So we have X will be from B. So this distance. Now unit load B to D, moment about B equal to 0, left part. Then we have RA into 3 equal to 0, and therefore we have RA equal to 0. So when unit load is between B to D, so it may be at C, it may be at D. X we have at C, we have X 2 meter, and at D we have X 7 meter. So RA we have 0. Now we will take moment about B0 right part. So we have moment about B equal to 0 right part. And then we will get it as value, that is 2RC. Then we have plus 7RD. And now we have this is equal to X. And second equation we have RC plus RD equal to 1, because we know we have value of RA 0. So RC plus RD now becomes 1. So if you multiply this equation by 2, then we will get it as 2RC plus 2RD, and that is equal to 2. And now when you subtract this, so we have this cancels, and then we have 5RD, that is equal to X minus 2, and therefore RD we will get it as x minus 2 by 5. Now at C, now you can check it at B. If we will put at B x equal to 0, then you can see x is 0, so minus 2 by 5. So this value minus 0.4 will match. And now we have RC plus RD. This equation already we have seen, and that is equal to 1. So if RD is 0.4, so RC we will get 1.4. This automatically satisfies. Now at C we have x equal to 2 meter, and therefore we will get RD that is equal to 0, because 2 minus 2 becomes 0, RD 0, and RC then becomes 1. So RD we have 0 and RC we have 1. So RC when unit load is at C, RC we have 1 and RD we have 0. Now at D we have x equal to 7 meters, and therefore we will get 7 minus 2. In this equation we are substituting 5 by 5. Therefore RD is 1. If RD 1, then we will get RC 0. So RD at point D, RC is 0 and RD is 1. So likewise we have this table, and then we are in position to plot the reactions. Now you can see these values which already you have seen, and now how to plot it. So I will show you how we can plot it directly. So that is easy method to plot directly. So we have this as 3 meters. This is RA. Then we have this as RB. And then we have this as RD. Now this is 5 meters. Then we have this as 2 meters. Now whenever we are going to find the values, then if I will find for RA, then my value of RA is 0 at B and D. So now first you have to keep in mind, whenever you are going to plot this for the reactions, so you should have this AB as one beam, AB, and then we have another beam in this we have, that is BCD. So I will plot it another color. So we have this as BCD. So now line of this AB, sorry, this is RC. So line of AB and line of BCD. So this line should be linear. AB should be linear and BCD should be linear. So now first I will plot for RA. So when I am going to plot for RA, I will directly tell you. So it is always 1 at this. Then we have value at C should be 0. So this I am plotting ILD for RA. So we have this should be 0 at C, and then we should have 0 at D. Now we know BCD should be linear. So I should have BCD linear. So this should be linear line. So when it passes through CD, we have horizontal line. So it should be horizontal till B. Then we are going to be same slope. Linear means my slope of BCD should be same. And now we know value at B we have 0 then. Then we will connect this. So we have this will be ILD for RA. Now you can see this values. If we will see for RA, we have at A1. So we have these values for RA, at B0, at C0, and at D0. So we have this will be ILD for RA. Now we will go another ILD, that is next ILD we have for RC. So now we will go for RC. So now you can see we will go in the same fashion. So let us, we have this will be ILD for RC. So now we have in this ILD. So value we should have 0 at A, and we should have 0 at D, and value at C should be 1. So we will plot accordingly. So we will have this. So at A we have 0, at C we have value 1, and at D we have value 0. Now I know we have B, C, D, this line linear. So what I will make, I will use same color for these lines. So you will again better understand this. So in this portion I will use red, and you can have, for red we should have same line. So I will have this as red, and we have linear line for this red. So 1. So now in this also we have linear line for AB, and for this we have line BCD. Now we know BCD points, so I will first plot for BCD. So we have 0 over here, 1 over here, so I will connect these 2 points. Now we know this color we have same, so till B we should have same continue, and we will be continue till B. And then we have to find ordinate at this. And now we know this point at B, so I will just connect AB, and we have again this line as linear, so I will linear line. So you can see red should have same slope, and that blue should have same slope. So we should have this same slope. Now what will be this value? So this value we can find. Now you can see this. So we have this distance, we have 5 meters. We have this distance 2 meters. If I will say this as y, then we have this distance as 7 meters. So now we can have y upon 7, and that is equal to 1 by 5. And from this we will get, therefore y is equal to 7 by 5, and we have 1.4. So you can see now this is ILD for RC. Now you can see ILD for RC, we have 0 at A, 1.4 at B, at C1, at D we have 0. And then you can see this. RC we have 0 at A, 1.4 at B, 1 at C, and 0 at D. Now we will go to the last ILD, and we have that ILD that is for RD. Now we will plot for RD. So now we have this for RD. So now we will go for values. So now we know we have value for RD 0 over here. We have value for RD that is at B, that we do not know. Value we know at C it should be 0, and we have value at D, that value we should have 1. So we know now 2 values, that is for BCD we have this value 1. And here we have 0, so I will connect this. Now I know this line should have linear till B, so I will continue it till B, so it will be continued till B. So we have same slope for this, and that should be linear, slope should be same. So I will plot slope same between this portion, and then we will get in this way. So we will have this likewise. So this value we do not know, we have to find this value y. Now we know at A0, B we have this value y. So again we have this linear line. Color you have to see, and that we should have linear line for these colors. So we have this will be 1. And now how to find y? So we have this as 2 meters, we have this as 5 meters, and then similar triangles we have these 2 angles, and we will get it as y by 2, and that is equal to 1 by 5, and then we have y is equal to 2 by 5, that is 0.4, but as it is below, so we have y as minus 0.4. And now you can see these values. So we have 0 at A, we have minus 0.4 at B, 0 at C, and 1 at D. And then likewise we will get values in this way, that is ILD for reactions RA, RC, and this is ILD for reaction RD. So we have for reaction RD. Likewise, we have to plot these ILDs for reactions. It may be combined compound beam, or it may be simply supported beam. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.